Hello student, myself Digant Sakhiwala, I am your science sir. Today we will continue chapter number 5, periodic classification of element. Dear student, we learned that there are so many drawbacks of Daubenier triad as well as Newland octaves and Mendeleev periodic table. So after that modern periodic table come in the existence by the discovery of X-ray atomic number by Henry Moseley. The modern periodic table come in the existence. So we will learn step by step. In 1930, Henry Moseley showed that atomic number of an element is more fundamental property than its atomic mass. Okay, so in Mendeleev periodic table, atoms are arranged according to the atomic mass, but the problem of isotopes, the scientists consider the atomic number. So atomic number is more fundamental than the atomic mass. The physical and chemical properties of element are the periodic function of their atomic number. Okay, whatever atoms are there, their physical and chemical properties are there. They are the periodic function of their atomic number. So their physical and chemical properties are mainly depend on what? Atomic number. Group and period. The modern periodic table has 18 vertical columns known as group and 7 horizontal rows known as the period. So modern periodic table, in that 18 vertical columns are there, they are called group. So vertical column, all columns are called group, and we can say that horizontal rows are there. They are called the periods, and they are 7 periods are there. Position of element. Element present in any one group have the same number of valence electron. Suppose element is present in the first group, hydrogen, then lithium and then sodium. They outermost orbit contain 1 electron. We will take example, hydrogen atomic number is 1, so 1 only. Lithium atomic number is 3, so what we can write? 2, 1, outermost orbit contain 1 electron. Sodium atomic number is 11, 2, 8, 1, so outermost orbit contain 1 electron. Like that, in all the groups, they have the same number of valence electron in their outermost orbit. Okay, you can take example of halogen as well as you can take the example of inert gas or noble gas. Okay, noble gas, in that helium is exception. As the number of cell increases as we go down the group. So dear student, we know that cell, orbit or energy state you can use as a synonyms. So as we are going top to down in the group, okay, we can see that the orbits are increases. Okay, like hydrogen 1 orbit only, 1 electron. Lithium 2 orbit, 2, 1. Sodium, we are going, then it is 11, 2, 8, 1. So first hydrogen in that 1 orbit, lithium in that 2 orbit, 2, 1, and sodium in that 3 orbit are there. So 3 cell are there or 3 energy states are there. Okay, so as we are going top to down, their cells, orbit or energy states are increases, and because of that reason atomic size are also increases. Element present in any period contains same number of cells. Also with the moving from left to right, the valence cell electron increase by 1 unit across the period. So period, in that what happened? Period means what? Horizontal row, that is called the period. Okay, horizontal row, in that the electron enter into the same orbit or same cell or same energy state. Group, in that electron enter into the new orbit, new cell or new energy state. Period, in that as we are going to left hand side to right hand side, electron enter into the same orbit, as well as because of the electron enter into the same orbit, their valence electrons are increases. We will take the example of hydrogen and helium. Okay, hydrogen, in that 1 electron is present. So as we are going in right hand side in the period, then what we are getting? Helium. Helium has 2 electron. In the same orbit, same energy state or same cell, 1 electron is added. So helium is 2 in the first orbit. Okay, so number of electron are increases, valence electron are increases, and electron enter into the same orbit, and because of that reason in the period when we are going left hand side to right hand side, size of the atom is decreases. Each period mark as a new electronic cell getting filled. Okay, each period marks a new electronic cell getting filled. Okay, so like first period in that first orbit, second period in that second orbit or second energy state are there, that is called L, like that. So like that we have 7 periods are there. Okay, 7 energy state are there, or 7 orbit are there, or 7 cell are there. Lanthanoid series. The element from atomic number 58 to 71 are called Lanthanoid series. You can see the atomic number from 58 to 71. They are called the Lanthanoid series because they are started from the lanthanide. They belong to group 3 and period 6 of the periodic table. Remember, dear student, the group 3 and period 6, in that we can see that we find the Lanthanoid series. They are named after the element lanthanum, atomic number 57. So the series name is given by the first element or first atom is present, lanthanum. From that the word lanthanoid come in the existence. Its atomic number is 57. Actinoid series. Similarly, element from atomic number 90 to 103 are called the actinoid series after actinium, atomic number 89. So actinoid series is come in the existence because of what? The first element is actinium and its atomic number is what? 89. So they are element from atomic number 90 to 103 are called the actinoid series. They belong to group 3 and period 7 of the periodic table. So they are belonging to group 3 and period 7 of the periodic table. The lanthanoid and actinoids are represented separately below the main periodic table. All elements of this series are radioactive. The element which emit the alpha, beta and gamma rays, they are called the radioactive element. Why they emit the alpha, beta and gamma ray? Because in that number of neutrons are more in quantity, and because of that reason, to get the stability, nucleus emit the alpha, beta and gamma rays, and it is called the radioactive element. Okay, and they are represented downward in the modern periodic table. Okay, trends in the modern periodic table. The trends in the elements are in the group top to down and period left to right. Okay, so we will see about what is the characteristic of elements or atom in the group top to down and in the period left to right, that we will learn. Okay, so we will check all the one by one all the characteristic of the atom. First, valency and electronic configuration. From top to down, top to bottom, in a group we see that one cell keeps on getting added from one element to the next. We take the example of hydrogen, lithium and sodium. Same way we can take the example of fluorine, chlorine and bromine. As we are going top to down, what happens? The new cell, new orbit or new energy states are increases. Okay, like we can take the example of fluorine. Fluorine is 9, so 2,7. Okay, chlorine is 17, so we can write 287. So you can see that fluorine, in that we can say 2 orbit are there, 2 cell are there, 2 energy state are there, whereas in the case of chlorine 287, so in that 3 energy state are there, 3 cells are there, or the 3 orbit are there, 2, 8 and 7. Okay, so when we are going top to down in any group, their cells are increases or orbits are increases. The element lying in the same group have the same outer cell electronic configuration and valency, and thus have the same chemical properties. In the group, all the atoms are there, any group are there, in that top to bottom their valence electrons are same, valency are there same, so their chemical properties are also same. Okay, on moving from left to right in period, number of atomic cell remains same and atomic number increase by the 1 unit. So when we are going in the period from left hand side to right hand side, the electron enter into the same orbit. Okay, we take the example of hydrogen to helium. Hydrogen is 1 electron, helium is 2 electron. Electron enter into the same orbit, okay, or same cell or same energy state. Okay, so the cell is remain same and atomic number increased by the 1 unit. We can take the example of lithium and beryllium. Lithium is 3, so 2,1, and 1 electron is added, then it is beryllium 2,2. Electron enter into the same orbit, electron not enter into the other orbit. Okay, atomic size. The atomic radius decreases in moving from left to right along a period. This is due to the increase in nuclear charge, which tends to pull the electrons closer to nucleus and reduces size of the atom. So atomic size decreases in the period because electron enter into the same orbit, same cell or same energy state, and because of that reason there is a more attraction. As there is a more attraction between nucleus, in that protons are there and electron, as we are going left hand side to right hand side, size of the atom is continuously decrease. Okay, and as the size of the atom is decreased, it has more tendency to gain the electron. So metallic characteristic is decreases as we are going to left hand side to right hand side. Non-metallic characteristic is what? Increases. The atomic size increases down the group. This because new cell are being added as we go down the group. So atomic sizes increases in the case of group when we are going top to down. Okay, we take so many example. In that we can take the example of beryllium and magnesium. Beryllium is we can say that 4, so it is 2,2, and magnesium is 12, so we can write 282. So as we are going top to down in any group, first group, second group, or we can say that inert group, then what happen? Electron enter into the new orbit. As electron enter into the new orbit, their size are continuously increased. Electron enter into new orbit, and because of that is an attraction between the valence electron present in the outermost orbit, and the attraction between the proton in the nucleus is also decreases, because distance between the nucleus in that proton and the outermost electron are increases. So in the group the size of the atoms are increases. It increases the distance between the outermost electron and the nucleus, so that the atomic size increases in spite of increase in the nuclear charge. So in the case of the group, as we are going top to down, the size of the atom is increases because electron enter into the new orbit, and because of that reason the attraction between proton and electron is what decreases, electron negativity. The relative tendency of atom to attract the sad electron pair of electrons towards itself is called the electron negativity. Dear student, don't confuse in the electron negativity and electron affinity. Electron affinity means when electrons are added in the atom, at that time energy is produced, that is called the electron affinity. Electron negativity means the tendency of atom to gain the electron, to attract the electron from the covalent bond or the sad electron, that is called the electron negativity. In a period from left to right, the value of electron negativity increases, while in the group from top to bottom the value of electron negativity is decreases. Electron negativity means what? The tendency of atom to gain the sad electron. So whenever we are moving from left hand side to right hand side, the electron enter into the same orbit, and because of that reason the number of electron added in the same orbit or same cell or same energy state, and because of that reason it has more tendency to gain the electron. So their electron negativity is increases when we are going left hand side to right hand side. But in the case of the group, electron enter into the new orbit, and because of that reason attraction is decreases. Okay, because the electron enter into the new orbit, attraction is decreases, so they have not that much electron negativity. Electron negativity is decreases, but their electron positivity is increases. Electron positivity means tendency of atom to lose the electron. Okay. Metallic and non-metallic properties. Metallic character decreases across the period and increases down in the group. Metallic character means what? If the atom is having less than 4 electron in outermost orbit, then they have the metallic characteristic. But when we are thinking about the period, when we are going left hand side to right hand side, electron enter into the same orbit. Because of that reason, as we are going left hand side to right hand side, we get such a type of element which has more tendency to gain the electron, so their metallic characteristics are decreases. Non-metallic characteristic means what? The atom in which the outermost orbit contain more than 4 electrons, they have the non-metallic characteristic, they have tendency to gain the electron. Metals, in that they have tendency to lose the electron if they contain less than 4 electrons. The metals are found at left, non-metals are found at the right hand side. We can see that metals are found at the left, whereas the non-metals are found at the right hand side, and at between of them zigzag line, in that semi-metals are present. They are also called metalloids. They have both the property of metals and the non-metals. In the middle we have the metalloids element which exhibit the some property of both metals and non-metals. These are boron, silicon, germanium, arsenic, antimony, tellurium and polonium. So we can use some word like semi-metal, metalloids or semiconductors, because they are present between the metals which are present on left hand side, and right hand side non-metal are there in zigzag line. We can see that boron, silicon, germanium, arsenic, antimony, tellurium and polonium is present. So dear student, today we learn about the modern periodic table. It's totally based on the atomic number, and we learn some characteristic of metals, non-metals. Okay. Thank you for watching.